All right, this video is going to be going over how to find inverses of functions and kind of analyzing whether that inverse is a function itself. So the notation we're going to use is this notation here, and it's important that you realize that this means that it's the inverse. It does not mean 1 over x, because that means reciprocal and not inverse. There's some more information here, including an example of some linear functions. One thing that must be true of all inverse functions is if you take the composition, so f inverse of f of x and f of f inverse of x, that these should cancel out with each other, and you should be left with x. If these are two inverses, then their composition should cancel out, and you should be left with x. So that's one way you can always check and see if two functions are inverses. You can also look at a couple of the coordinate pairs and see if their x's and y's are switched. That's another indicator that two functions are going to be inverses of each other. And then again, here are some little snippets from the text. So if I have these two functions and I want to know, is g the inverse function of f? That's what that means. Well, one thing I can do is take the composition and see if I get x. So I'm plugging that in for x plus 2. All right, these cancel, and I'm left with 1 over x. If I multiply by the reciprocal, I end up getting x. All right, if I have g of f of x, because they both you need to check both of them, then that's g of f of x, and I'm going to plug that in. That's not correct, sorry. It's 1 over, and then in place of x, I have that, and then minus 2. Okay, let's work with this fraction first. Again, I'm going to multiply by the reciprocal. I get x plus 2 minus 2. These cancel, and I'm left with x. So yes, those two functions are inverses of each other. All right, let's go ahead and look at another way we can talk about inverses. So this gives us a function, which is the distance that has been traveled after t miles. It says find and interpret what this is. Well, another way to write that is f of t equal to 70, right? Because these would be opposites. So whatever like f of t equals y would be the inverse, like those two things would be switched of each other. So if I have this given to me, I like to rewrite it. So I'm like, when is f of t equal to 70? And so like at 90 minutes, the distance traveled is 70 miles. All right, let's look at a graphical example. So if I want to find g of 3, then that means I'm looking at x equals to 3. So g of 3 gives me 1. But if I want to find g inverse of 3, then another way to write that is like, what is the x value when my output of g is 3? And so I'm actually going to look here and drop that down, and that's going to be equal to 5, or x equals 5. And then our last example for inverse functions is if it's just like, hey, find the inverse of this function. Then what we do is we switch x and y and then solve for y. So let's subtract 4 first. Then if I want to multiply this over to get rid of my denominator, I can. And then I'm going to divide by x minus 4 on both sides. So y minus 3 is equal to 2 over x minus 4. Then I'm going to add 3. And this would be f inverse of x.